Good morning. Tuesday, December 16, 9 a.m. I'd like to welcome all of you to our today's webinar. And our today's webinar deals with a topic which belongs to everyone in the world. We are talking about fresh and clear air. My name is Manuel Gauss. I am the corporate team leader of the corporate sensor product marketing team at Rutronik. And I'm happy to have the company Sensirion here today, here in Ispringen, in our Rutronik headquarters. Next to me is Aaron Döring. He's the area sales manager at Sensirion for the DACH region. And also a warm welcome to David Caminati. He's the product manager at Sensirion for the combo sensors and environmental sensors. Thank you to have you here.
Yeah, thanks for having us.
Thank you.
Today, as mentioned, we'll talk about the newest combo model from Sensirion, the SEN6X, which measures up to 9 different environmental parameters and formaldehyde, CO2, and particulate matter. David, what was the inspiration for Sensirion to develop this kind of combo module?
So actually the reason that we developed the combo module was that our customers, they were telling us that sensors are not as easy to integrate as other electronic chips. And we have the expertise, we know how they work, we know where we need to take care of certain aspects and also the compensation algorithms. So we wanted to provide a complete solution that is a plug and play sensor for our customers. So this is why we developed the combo module, to make it as easy as possible for our customers and they can focus on their expertise in their application.
Okay. Yes, very good. Good to know. And in the next 30 minutes, you will learn more about this combo module from Sensirion, the SEN6X. Therefore, I would say thanks again to have you here. And David, I would hand over to you to start with the presentation.
Yeah. So actually, Aaron will do the first part. Yeah. So we can start here.
Yes, thank you for the introduction, Manuel. Great to be here with Rutronik today in the morning. And we're living in times where people are really aware of well-being, health, comfort. And this especially is true, for example, with respect to people's dietary intake, as well as with water, liquids people consume. So people are really much aware of health benefits as well as dangers to health from, for example, drinking unsafe beverages, liquids, and so on. So when you look at the numbers, for example, people are drinking on average 3 liters of water per day. People care about this. On the other hand, if you think about air, so people are breathing air constantly, 24/7, which amounts to a huge amount of volume of air that people are taking in across the day. So we're talking about on average 11,000 liters of air that is breathed in, breathed out constantly. And of course, with this comes all of the pollutants, so particulate matter, for example, but also different kind of gases. So CO2, for example, VOCs, formaldehydes, for example, which all either are going to be stuck in your lungs and have health effects there, or even being transmitted to the bloodstream or even to your brain. So there's a huge potential to look into optimizing or monitoring the quality of air, just because it's around us all the time and we are spending so much time breathing the air around us. So this is something as well that maybe people often could consider a problem to be in an outside environment in certain regions, for example. But actually, according to studies, 99% of the global population breathes air that exceeds the WHO air quality limits. So this is threatening health for a very, very big majority of people on the planet. And there's also, so you can always see probably smog outside in certain kind of cities, in certain regions, but actually humans spend 90% of their time indoors. And actually air quality levels are typically worse indoors. So 2 to 5 times the pollution is typically present indoors in closed rooms compared to outside air quality levels. And so this makes it very, very it's a potential, very, very potent to look into studying, controlling, applying air purification and air monitoring inside closed rooms. And while air pollution, air quality is a very, very complex topic to study, 98.6% of the health damage is actually caused by a very limited set of factors. So we have particulate matter on the one hand, formaldehyde, and nitrogen dioxide. So these are aspects we can study and then use this information for well-being, for health, for comfort in indoor applications. And so indoor air quality can be a complex topic to study. So as mentioned, so we have particulate matter, for example, we have formaldehyde, we have nitrogen oxide compounds, but of course we also do have other parameters that are important to study. So CO2, for example, the humidity of the air, temperature. So there's really a range of parameters that you can study and that people may care about. That's one aspect. On the other side, you do have a range of building standards, for example, that people may want to adhere to have their system conform to certain green building standards, or to even have the overall building complying to these regulations. So it can be quite a complex and expensive endeavor to study air quality, but it doesn't have to be. This is where Sensirion is coming with the SEN6X family. This is our all-in-one solution as a product for your indoor air quality needs with really 2 benefits. One is to reduce time to market for you as integrator, and also to really reduce the integration costs on your end. And when we developed SEN6X, so the SEN6 family, we had in mind basically 4 aspects to optimize performance and value for customers. One was to really cover all of the parameters that account for most of the contaminant-related harm. Second is to have this effortless indoor air quality monitoring through this advanced technology that we're offering at Sensirion. The third is to have this maintenance-free, long-lasting technology, especially for particulate matter. And the fourth is to save time and effort in this plug-and-play setup. So first I want to cover on the first aspect to discover all of the parameters that we are covering in the SEN6 family. So we basically offer the SEN6X as a modular platform. So as you can see on the right side, the image of the physical design of the product is one for different kind of combinations. So depending on your use case, you can use this one physical design and basically integrate all of the different parameters that are important for your specific application. So when we look at this circle on the right-hand side, we see all of the aspects that we are covering in the application. So for example, all of our combo SEN6 modules have PM, so particulate matter detection inside, as well as temperature and relative humidity. We also then have variations with formaldehyde, HCHO, CO2, NOx, VOC. So there's really a bouquet of different sensing parameters that we're offering. And what you can see in the table on the left side is then all of the possible variations that we have in stock. So it starts with just PM and temperature and humidity, and then different combinations that include then CO2, formaldehyde, VUC and NOx. And as they all have the same physical design as well as electrical connection, this also allows you to quickly change variants for specific models. So for example, if you're integrating or want to expand into a new region globally, where there may be an interest, for example, in formaldehyde sensing in that certain region, you can just plug and play really with different sensor modules. You can change, for example, from SEN6X to SEN68 or 69C, and then you just have this other parameter available in your project. So what you can see here is an example of this really modular design. So all of the same physical out shape, different PCBs, different sensors on there to really allow this modularity for different applications. Just a quick overview of building standards that we are supporting. So this is mainly the Reset Well California Title 24, as well as LEED and ASHRAE certifications. So all the individual sensor components are conforming to these standards as needed. This will be a very good topic to have a deeper conversations about. Or if you are curious, we also do have a lot of application notes and further documentations on our website available for you to study these norms and regulations in detail for your projects. I'd like to dive into a couple of technical aspects just to highlight a few key features of these products. One is on CO2 sensing. So all our sensors do offer real CO2 measurements. So we have one example here on the left-hand side of actually our SCD4X series, which is a CO2 sensor that is integrated into some of these SEN6X variants. And they work with photoacoustic technology, which is very, very specific to just CO2 molecules by basically exciting the CO2 modules with a certain wavelength of laser light, and therefore specific just to this kind of molecules, which allows very, very specific measurements of these CO2 compounds. And in many solutions on the market, actually CO2 is a derived measurement. It's an estimation on these VOC compounds. And on the right-hand side, you can see that. So this eCO2 estimation on VOCs depends on quite a wide range of aspects of activities, events in a building. So it can be, for example, alcoholic beverages, which would increase the VOC levels in air. It also can be, for example, paints, cooking events, candles, besides the presence of humans in these environments. So therefore, eCO2 products are really estimates, and their precision widely depends on what exact activities are happening in a certain space. So therefore, with Sensirion's CO2 measurement solutions, we really offer plug and play CO2 measurements that are very specific just to this event. And this can be very helpful for quite a range of applications. A second thing I want to focus on is formaldehyde, which is really a hidden indoor threat. So it's a carcinogenous molecule, very, very low levels. So actually even 80 ppb parts per billion over a 30-minute time frame can be dangerous according to the WHO. Formaldehydes are, for example, present in different kind of paints, in furnitures, in glues, and so on. So monitoring formaldehyde and then being able to filter these in air purifiers is a very, very important aspect of purified air in indoor environments to make sure that all of the inhabitants are safe and well. So going from technologies now to applications. So how can we use the SEN6 module in customer applications? And of course, two things that really come to mind are either air purifiers as well as indoor air quality monitors, but there's much more than this. So talking about, for example, residential applications, this is really can be helpful for increasing health, comfort, and safety in living spaces. So for example, for baby monitors, in smart speakers, monitoring the health and safety of the air, as well as then extending this to commercial buildings. So for example, conference rooms, networking equipment, and also in this aspect already. So vape detection is one thing we want to focus on, which refers to detecting this new e-cigarettes usage, for example, in schools, in hotel rooms, in rental cars, and so on. Another aspect can be mobility and transportation, so focusing on safety and comfort in cars, for example, as well in aftermarket indoor air quality monitors. And the last thing can really be environmental monitoring, so focusing on smart infrastructure, security devices, doorbells, and so on. So let's continue with a kind of deep dive into some of the applications. So one is sleep quality. So we all spend 8, 12 hours probably in the bedroom every day. And it's amazing how fast CO2 levels can rise up in smaller rooms, for example, in a bedroom. And CO2 really quietly steals your sleep quality. So the higher CO2 levels raise in a room, it makes people fall asleep later. It will basically have people wake up more intermittently during the time. People wake up earlier in the morning. So CO2 levels really can have quite adverse effects on sleep quality. And with this, of course, on well-being of the persons who are using this bedroom. So even reaching CO2 levels, for example, of up to 1,000 ppm can have a significant effect on sleep quality. And this is something which can be addressed with monitoring, with indoor air quality monitors and air purifiers. Another application already addressed before is this topic of vape detection. So these e-cigarettes can really have are very popular right now, and they have, well, a really complex emission of different particles. So PM is visible there, CO2 is emitted from these vapes, as well as some VOCs, for example, so other volatile organic compounds. And they are often consumed in public spaces, for example, in public buildings, in schools, but also hotel rooms or rental car may see people using vapes, even though they are forbidden to use them in these areas. And vape detection can really help to monitor, to control this use of public spaces via this bouquet, this variation of different sensor parameters. One last thing I want to focus on is in car and hospitality, especially for this health aspects of virus load. So when you think, for example, about a taxi, an Uber car, where you spend time in a very, very confined space, a couple of cubic meters of air with a couple of passengers, with a driver, and it takes very, very short time at increased CO2 levels to breathing in exhaled air from previous occupants. So CO2 is a very, very good proxy for basically monitoring the virus load, for example, by monitoring the exhaled air from other occupants. And monitoring this really allows to understand and also then to act and control on the air quality in such environments. So for example, changing in a car or in a taxi from the circular airflow to fresh air, or just opening the window because it is very apparent that the air quality is not good enough for health levels. This then brings us to the technology in the SEN6X series. So David, stage is yours to continue on our journey.
Thank you, Aaron. So yeah, I would like to dive a bit into the technology that we use here, what sets us apart, what is special for the SEN6X. And so Aaron said we have 4 different areas that we've been focusing on. The take-home messages, if you just remember 4 little sentences from this talk, and one is really effortless indoor air quality, and there how we are using industry-leading technology. So obviously this is an online presentation and it's hard to gauge the size of such a module. And here we see what it looks like next to a matchbox. And some of you may even know the previous generation SEN4X or SEN5X of our combo modules. And as you can see, it's roughly half the size despite featuring now even more sensors inside. So this is a really compact solution that has all the air quality features inside that you could need. So how are we able to actually shrink the size while cramming in even more sensors? And the key factor here is what we see on the left, a PCBA where we've been using the particulate matter sensors in the past. They're made up of a lot of discrete components. So you have the laser, the PCB itself, the photodiodes, all of the electronics for the analog and digital part. And now we developed this chip, and this is to scale. So you can see this chip is much smaller than everything here on the PCBA. And this integrates everything you need for a particulate matter sensor. It still works the same way. We can see here on the right with particles in an airflow that are drawn through the laser beam and scatter some light back. And then all of the circuits to measure this and also the digital part, it's all integrated into this chip. And this really allows us to shrink the size down. So we have a lot of sensors inside the SEN6X, but I want to focus a little bit on particulate matter. For one, because it's the heart of the module, so it's the basis that we have everywhere. But also because on the health side, we saw that it's actually having one of the largest impacts on the health effects. So when you're looking up particulate matter, you often see those numbers, PM10, PM2.5, PM1, but what do they actually mean? So what they mean, the number that you see behind it is the maximum size of particles. So PM1 is everything from 0 up to 1 micrometer. And then if you look at PM2.5, because it's everything up to 2.5 micrometers, it always has to be bigger than PM1 because PM1 is included in this range as well. And the reason for this is because it historically has been measured with filters where you got rid of the bigger particles and then the rest you filtered. So this is the 3 most common sizes that we have. But how small is this actually? So here we see an example of a human hair, and this is usually between 50 and 70 micrometers in diameter. And then we see some fine beach sand, and on the bottom left we even see a red blood cell. So this is what we would have inside of our blood, and all to scale. And if we have a look then on the blue balls that we can see here on the hair, this would be 10 micrometers. Then PM2.5, those are the small red dots that you can see there. And the particles, so 2.5 micrometer, this is just the biggest one in particulate matter. So we're really talking about something that is 3 times smaller or even more than the blood cells that we have, something that you cannot see by eye, and the sensors are individually detecting. Why should you care about particulate matter? The main thing is really that the smaller particles are, the further they can penetrate into your body. So here actually size does really matter, and the smaller the more dangerous it is. Because PM10 particles or particles that are 5 to 10 micrometers big, they stay in your upper respiratory system. But when they get smaller, they can get into your lungs. And PM1 particles are actually so small that they can penetrate your lung blood barrier, go into your blood, and from there be transported all around your body. And when those particles are deposited, your immune system will attack it. It will cause small inflammations. The cells will reproduce there, and then you can also get mistakes in this reproduction, and it can lead to cancer, but also less severe effects like the eye, nose, or throat being irritated, and it can also cause asthma, heart disease. So roughly 70% of the health effects from air pollutants is just from particulate matter. So this is really important. And if you have a look at the limits that certain governmental bodies set, we have the European Union that is currently setting 25 micrograms per cubic meter as the annual limit. But by 2030, this is going to be reduced to 10. And in the US, from the EPA, it's already at 15. And next, I quickly want to show you what kind of options there are on the market to measure in a consumer space particulate matter. and only laser-based sensor can really measure this accurately enough to comply with those standards. So what are the two different technologies that are out there? For one, we have the laser sensors, which also our module, the SEN6X, is part of. And there, the laser beam is so tiny that it really detects individual particles. And LED sensors, on the other hand, they are much less precise, much bigger detection volume, and they always measure a cloud of particle. But you may ask, why does this make a difference? Yeah, here. So actually for the laser sensors, if we have a look for the engineers to go a little bit into the detail here, we can see when we have a photodiode, we always get some noise. So this is just electrical noise that you cannot get rid of. And when you have particles, they generate individual peaks. And this is what we can see actually here. And then depending on the size of the particle, we get a different size peak. And in the end, this is what the sensor, the raw signal is seeing. And when we have low PM concentration, so few particles in the air, what we actually want to have, then we just get few peaks, but the signal to noise ratio always stays the same. So the noise to the signal, this distance always stays the same. When you have a look at the LED sensors in turn, then actually there we have the same photodiode, but because we're always measuring this cloud of particles instead of individual particles, we can for one not say how big the particles are. And we know smaller particles are more dangerous. And also when we go to smaller sizes or smaller concentration rather, then the signal is much lower and our signal to noise actually drops a lot. So we have then a bad signal to noise ratio. So in the most relevant area where you want to measure, those sensors cannot do it properly. So you really need to use laser sensors if you want to measure particulate matter in the relevant range. So the other thing is maintenance free. None of you want to replace sensors frequently, and this is really a pain point that we see on the market and hear a lot from customers that PM sensors, they're not so reliable, they're sucking in a lot of dust, and then they get polluted over time and the signal degrades. And this is something that we addressed with our patented sheath flow technology. What it does is we have two different inlets on the module. You see one inlet where we see a white filter and we see a black inlet where it's just a channel leading into it. And what we do is right in front of the optical components, we inject this clean air and wrap it at the dirty air in clean air. And what this does, it protects the optical components from being polluted. So the particles do not settle on it. And this way we say we can operate this sensor for 10 years, 24/7 operation in air conditions that would be equivalent to Beijing in China outdoors. So which is 35 micrograms on average. And this for 10 years. This is how long the sensor is protected and stays within the specification. If we have a look what this actually looks like, so this is after an accelerated lifetime test with standardized Arizona road dust, and we can see on the top right, the SPS 30, it uses exactly the same technology that we also have on the SEN6X, and we see dust is settling in the channel, but the photodiode itself actually stays clean. And on the bottom, we see a competitor module that doesn't use our patented sheath flow technology. And there it's completely blocked and you will not get a signal out of it anymore. So it's really just those optical components that are protected by the sheath flow. And with this, it can measure even after 10 years accurately. And then the last message is we provide you a way to save time and cost. So it's a plug and play setup. It's one interface. You don't need to worry about drivers for all those different sensors, the integration for all of them, no tools, no extra development. So this allows you to focus on your expertise, on the products that you want to bring to the market, and we take care of the sensing solution. So what this means is really the integration cost for you goes down a lot. You don't need to spend the R&D resources, but also in production, it's just one module that you can click in. It's just one cable and one electrical interface that you need to talk to. So with this, we continuously make it easier. So in the beginning, we have sensors that are measuring all the pollutants individually. We had then the SEN5X that already integrated temperature, VOC, and NOx. And now with the new generation, the SEN6X, we also have CO2 and formaldehyde as an option for you. So for you, this also means you can use cheaper components, for example, on the microcontroller, because you don't need to integrate the drivers for all the sensors. You don't need to do those algorithms to compensate for it. And I quickly want to dive into the temperature compensation as my last topic. So you don't need to take care of that on your end. You just communicate with the Sensirion and have the rest of your application code. So this also allows you to save time and money on your microcontroller selection and development. So why is a temperature compensation needed? Isn't the sensor accurate enough? Well, the thing is, the sensor is very accurate to measure temperature and also relative humidity, but it can only measure the conditions where it's actually at. So when we have a temperature and humidity sensor alone, a standalone one, then it's very small, it has a low thermal mass, and if there is a change, so for example, somebody opens the window and cold air comes in now in the winter, then it will change quickly. When we integrate it into a module, it adds thermal mass, and therefore the response is going to get slower. And this we already compensate from the factory, but then when you integrate it in your device, and this is really per device different, it gets even slower. But the beauty is we already have a compensation algorithm in there that you can tune with our app notes, and it will take care to speed this back up again. And the same is true also for the offset. So if you have a pure standalone sensor, it doesn't consume much power, and therefore it will measure the ambient temperature. In a module, it uses some power. There's a fan in there. There's also other sensors in there that consume some power. So you will see slightly higher temperature, and the same in your device. So wherever electrical power is consumed, you also generate some heat. And also this can be compensated. So you don't need to worry about all the physics, and there's even more effects than this that the compensation algorithm is taking care. You just can follow our easy application note, do the measurements that we guide you through, and send those parameters that are determined to the module, and you directly get fast and accurate temperature and humidity signals out of it. So the last thing for me to say is get your evaluation kits now. So we're here today thanks to our partner Rutronik, and I quickly want to show you where we're at the moment. So we're launching this platform staggered. We have the SEN6X that is already available, as well as the SEN6X and SEN6X. And now in the following months, we will also launch the remaining 3 variants. So you will be able to have the full flexibility to choose the variants that are relevant to your application. So with this, I'm at the end of my part, and we're happy to get your questions.
Thank you, Aaron. Thank you, David. As mentioned, if you have any questions, please feel free to use the chat function and ask questions. Maybe I have a question. Aaron, you presented a very nice and a very new application, the wave detection in the public buildings, in taxis, public transportation. Does Sensirion has a special algorithm for this kind of measurement? Aaron, David?
So maybe you want to take this question, David?
Yeah, so we see that this is a growing demand for wave detection. And we thought about if it would make sense to integrate this algorithm as well on our end. But what we found is that our customers actually prefer to use our combo module to get the different sensor outputs, but then do the algorithm on their end. Because the reasoning there was this is how they differentiate themselves from different players on the market. So actually Sensirion does not offer the wave detection algorithm itself, but just the combo module that provides you with all the values that go into this algorithm.
Okay. This really like shows the value we're bringing to the customers. So we take care of all the hardware, the integration, the compensation of the different sensor parameters, and then our customers, users can really differentiate themselves and build a solution kind of starting from having all the parameters in place, an easy to integrate solution, and then add their value to their own end customers.
Thank you. Let me check if there are some further questions. Yeah, in the meantime, it's was a very, very interesting presentation. As mentioned before in the beginning, it belongs to everyone, a fresh and clean air. So if you have some application ideas, if you need support, please get in contact with the Rutronik sales and FAE team, and we are happy to assist you in together with Sensirion, David, and especially for the in the DACH region, Germany, Austria, and Switzerland, together with Aaron. Please get in contact with as mentioned, with the Rutronik sales and FAE team, and we're happy to assist you in designing in the Sensirion combo module SEN6X. Here you see again you see still the complete portfolio, and as David mentioned, there will some parts coming in the next months. There are no further questions. Thank you for the participation at this call, and we wish you Merry Christmas.
Thanks, everybody.
Thank you.